Hello and welcome to this presentation about my term project for CS6795. My name is Nivedita, and the research question I investigated was, how does the use of an AI coding assistant during debugging affect novice programmers' understanding of code, forming of mental models, and ability to transfer debugging strategies to new contexts? What got me interested in exploring this question was noticing that when working in industry, companies are encouraging developers to use AI more and more, whether that's through IDE extensions like Cursor, CLI tools, AI agents trained on company documentation, or even external LLMs like Claude. Of course, using these tools leads to an improvement in productivity, especially in the short term, but I wondered if it was coming at the cost of impacting my base coding ability. One of the most important skill sets for a developer to have is debugging skills. When a program doesn't work the way you want it to, you have to understand more deeply about how the different components of the program interact, and identify likely culprits by tracing the behavior down to something like a few lines of code. In effect, understanding a code base generally involves forming mental models, which are internal cognitive representations that help you simplify what's going on into an abstraction that's easier to work with. For example, we call things factory methods if they always create some type of object with X and Y features, but specific implementation can be overridden. It isn't exactly like a factory, but it's a useful enough analogy that reduces the cognitive load of understanding code. Prior research shows that debugging ability is correlated with coding ability. In this course, I didn't have the time frame to conduct a longitudinal study evaluating software developers' skills over the duration of their careers, but we can scale down and instead consider an isolated instance of learning that happens at the beginning of one's coding journey. Bugs can be classified in several ways, such as off-by-one errors, recursion depth errors, and more. A beginner at coding, when encountering new types of bugs, will typically try to form analogies to previously encountered bugs, which will help them fix the bug faster. Now let's discuss the design of the study. I interviewed 15 undergraduate first-year students, all from Southern Ontario universities, but mostly University of Waterloo, University of Toronto, and Wilfrid Laurier University. These students were all studying computer science and self-rated their coding proficiency as beginner to intermediate. Their compensation was a $10 Tim Hortons gift card. Each interview lasted up to 60 minutes, though a lot of them ended up being shorter because the participants answered the questions faster than the allotted time. We held them over Zoom and used one compiler to ask the coding questions. One compiler is a free online tool for code sharing, and it has a compiler so participants could run tests too. Each participant also shared their screen so we can keep track of which resources they used for help. Out of the 15 students, 8 were assigned to an AI group, and 7 were assigned to a control group. The control group weren't allowed to use any AI assistance, but they could still search questions on Google, use Stack Overflow, read documentation, and use any other internet resources. The AI group was allowed to use ChatGPT and ask anything they wanted to. The interview had 3 phases. In phase 1, the participants were given 4 short programs one by one, and each one was written in Python and had some kind of bug. They also had unit tests given to them and were encouraged to write more if they wanted to. The unit test allowed us to quickly check if their solution was correct. Then they had 5 minutes to fix the bug in the program. After that, they also had to explain their fix, and I graded their explanations on a scale of 1 to 3, with 3 being a fully correct solution and 1 being an incorrect solution. In phase 1, every participant got every question correct, as in they found and fixed all the bugs. However, the quality of their responses varied. The AI group had a mean score of 10.9 out of 12, while the control group had a mean score of 11.4 out of 12. This is a 4% difference. In phase 2, participants were asked to checkpoint the value of variables at different points in a program, which explicitly tests the accuracy of their debugging. There was no explanation required here, we just graded for correctness. The AI group had a mean score of 4.50 out of 5, and the control group had a mean score of 4.57 out of 5, so that's a 1% difference. Finally, in phase 3, participants were asked to fix a new program. They were measured on how long it took them and how well they explained their solution. The AI group took 35 seconds on average longer than the control group. The AI group's explanation score was also 16% lower on average than the non-AI group. Notably, in phase 3, neither groups were allowed to use AI. The results do show that the use of AI leads to slightly worse explanations and slower transfer of learnings to new, unseen bugs. However, phase 2's results were too similar to be statistically significant. It's important to address limitations of the study. 15 students is a small and not ideal sample size, and due to low participant interest, I couldn't be as selective with factors like years of experience coding. It's possible students randomly assigned to the control group were just stronger programmers. I also didn't classify how students used AI, such as whether they were copy-pasting entire questions or whether they were asking thoughtful questions. It's possible that being observed by an interviewer made them change how they normally interact with ChatGPT. So more research needs to be done here with larger sample size over a longer period of time. That brings us to the end. Thank you for listening to this presentation.